All right, in this one, we are continuing on with simplifying some trig expressions. We're trying to simplify these things down to just a value. Again, that's kind of our goal. When we start doing verifying, we're going to know exactly where we should be heading with this. But right now, we're just trying to see what we can do, put things together, and see if we can narrow it down to one value. So here are some of the pieces that we're going to do. We have some trig identities. When you see squares, it has a tendency to be these Pythagorean identities. So we'll see. So first thing that I see, I'm going to show you two different paths on this one. And again, it doesn't matter. You're going to end up in the same spot. When I see these two, I'm looking at kind of a distribution kind of feel to this. And if I do distribute these things together, they are reciprocals of each other. And reciprocals are going to cancel out. So I like that path. Now, it's not the only path. We'll show you another one in a second. But if you distribute this together, you have sine squared times cosecant squared. And then minus sine squared theta. Because sine squared times -1 is -1. This, they cancel each other away and just become 1 minus sine squared theta. And this, 1 minus sine squared theta is a thing. We got a 1 minus sine squared theta here is equivalent to cosine squared. So I can simplify this to cosine squared. All right, so that's one route. Another route is instead just the recognition like, that feels like that might be something right from the get-go. So cosecant squared minus 1 is cotangent squared. Now, maybe that's going to be a good thing. Maybe that's not going to be a good thing. As far as the more challenging route, we don't know. So let's start with, we'll just substitute that out and make these two multiplied to each other. So that whole value just becomes cotangent squared. Now, cotangent squared is cosine over sine, but just with squares on them. So you're looking at sine squared theta and then times cosine squared theta over sine squared theta. And these two are going to be multiplied together. I'll make it a fraction times a fraction, and these cancel each other away, leaving you with cosine squared theta. So that's at least two of the, I'm sure there's multiple routes that we can go beyond that, but there's two different routes of taking and getting the exact same thing. So on the second one, we're looking to try to put this together. We're trying to put the fractions together. First thing I see is the fact that you have a secant in the denominator. A secant in the denominator can just come up and become a cosine. So that's probably my fastest, most efficient way of doing this. Same thing with the secant or cosecant. So if you bring this up, it's going to become a cosine, and you already have a cosine. So that's going to become cosine squared. And then if you bring up cosecant, it combines with the sine that's already there and makes it sine squared, because cosecant in the denominator is sine. So if you bring that up, you can put these two together. So you simplified it, and cosecant squared, or cosine squared plus sine squared, is kind of one of our biggest ones. Just this, the order switched around, which is not a big deal because of addition. So sine squared plus cosine squared, so this whole value becomes 1. And that's it. Sometimes they work out that they're not a whole lot of steps, and sometimes they're a little bit more. But that was part 2, and then we'll eventually start doing some verifying identities, which should be a little bit more challenging. Thanks.